Welcome to this explainer. Today, we're diving into the absolute hero's journey of the Universal Serial Bus, a wild 25-plus-year ride. We're going to trace exactly how this tech evolved from an absolute tangled mess behind your desk into the sleek, single-cable reality we all live with today. It's honestly a fascinating story of engineering, a whole lot of consumer frustration, and, well, ultimate triumph.
Okay, let's take a quick look at our roadmap. We're going to cover escaping the port jungle, the need for speed, Type-C and naming nightmares, one cable for everything, and finally, why shape does not equal speed. Let's get right to it.
Section 1. Escaping the port jungle, the 1996 USB revolution.
To really appreciate where we are now, you gotta remember that before USB, the back of your PC was just a chaotic, colorful jungle of totally different ports. Buying a printer meant dealing with one massive thick cable. Your keyboard used a PS2 port, your mouse used a different one, and your scanner, that needed something completely different. It was literally a game of plug and pray. You had to shut down your entire computer, plug the device in, restart Windows, and sometimes fight with IRQ hardware conflicts just to get your PC to see the thing. But then, a massive coalition, we're talking Intel, Microsoft, IBM, and Compa, teamed up. They promised us plug and play, one single universal connector to replace that entire jungle.
So released back in 1996, USB 1.0 gave us maximum speeds of up to 12 megabits per second. Now, look, I know 12 megabits per second sounds painfully, agonizingly slow today, like it would literally take hours to transfer a modern video file, but in 1996, it was absolutely revolutionary. It was plenty fast to run a joystick or a keyboard perfectly smoothly, but here's the real kicker. The cable delivered 5 volts of power directly to the device. This successfully killed off the need to have a heavy, separate power brick plugged into your wall for every single tiny accessory on your desk. Though I should mention that early 1.0 version was pretty buggy, and it wasn't until USB 1.1 in 1998 that it became reliable enough to completely take over the world.
And honestly, this brings us to the absolute most magical feature of early USB, hot plugging. Think about how much we take this for granted today, right? Hot plugging meant you no longer had to totally restart Windows just to change out your keyboard or plug in a mouse. You simply pushed it into the slot while the PC was running and boom, the system detected it instantly. I mean, that was just pure magic for the late 90s.
Moving on to Section 2, the need for speed, flash drives and HD media.
Then, in the year 2000, USB 2.0 arrived and completely changed the landscape. It bumped the maximum speed up to 480 megabits per second. That is an incredible 40 times faster than the previous generation. Suddenly, the USB port wasn't just a convenient way to hook up a keyboard, it became the ultimate standard for digital storage.
When you look at this 40 times speed jump over a single decade, the impact is wild. A 700 megabyte CD could now be transferred in minutes instead of hours. This is what completely kicked off the flash drive revolution. People just stopped carrying CDs and started tossing tiny thumb drives in their pockets instead. It also meant digital cameras and MP3 players could plug right into your PC without a hitch. And then, to handle even larger high-definition files, USB 3.0 hit the scene in 2008, pushing speeds to a massive 5 gigabits per second, which let you copy entire HD movies in just seconds.
So how did they achieve this massive leap with USB 3.0? Well, engineers actually had to change the inside of the cable, increasing it from 4 pins up to 9 pins. By adding those extra pins, which you'd usually see hidden inside those iconic bright blue ports on your computer case, engineers unlocked full duplex communication. Simply put, this means the cable could send and receive data at the exact same time. It was a huge breakthrough. It let professionals use super-fast external solid-state drives and transfer raw photography without hitting massive bottlenecks. Oh, and it also nearly doubled the power output, keeping those power-hungry devices running smoothly.
All right, Section 3, Type-C and naming nightmares, a comedic conflict.
By 2013, the standard evolved into USB 3.1. Doubling speeds yet again to 10 gigabits per second. But honestly, the biggest innovation here wasn't even the speed, it was the hardware itself. We finally got the tiny reversible Type-C connector. After nearly 20 years of awkwardly flipping cables upside down and back again just to figure out which side was up, Type-C finally let us plug things in blindly on the very first try. Plus, it introduced way smarter power delivery. Instead of just a tiny trickle of electricity, it can negotiate much higher power levels, eventually delivering enough juice to charge an entire heavy-duty laptop right through the exact same port you used for your mouse. Talk about a game changer.
But brace yourselves. Prepare to be frustrated. Because rather than keeping things simple, the USB group randomly decided to start renaming the old standards. USB 3.0 was suddenly relabeled USB 3.1 Gen 1. The newer version was then called USB 3.2 Gen 2. This renaming created an absolute consumer trap. You could literally be walking down the aisle at an electronics store, look at two products with incredibly similar-looking marketing labels on the box, but inside, they had completely different maximum speeds.
Okay, moving past those confusing names and getting back to the actual tech, in 2017, they released USB 3.2, pushing speeds to an awesome 20 gigabits per second. How did they manage that? Engineers cleverly achieved this by adding a second data lane right inside the cable. Think of it exactly like a highway. If USB 3.1 gave you one fast lane of traffic, USB 3.2 gave you two fast lanes, working together at the exact same time. Your traffic doubled, your transfer speed doubled. It quickly became the absolute favorite standard for professional video editors running massive 8K workflows off external SSDs without a single stutter. Which brings us to Section 4, One Cable for Everything, the climax of USB 4.
Looking at this incredible speed journey across the years, it's wild to see how USB evolved from a basic little accessory plug used for typing into a heavy-duty digital interconnect. I mean, we've gone from 12 megabits all the way up to an astonishing 40 gigabits per second in 2019, and even 80 gigabits recently. Just a massive evolution.
That 40 gigabit milestone in 2019, that was the launch of USB 4. Borrowing some major technology directly from Intel's Thunderbolt 3 standard, USB 4 officially started the era of one cable for virtually everything. A single cable could now carry high-speed data, output gorgeous high-resolution video to monitors, deliver smart device power, route PCI signals, and even handle networking, all at the exact same time. It effortlessly handled tasks that used to require literally dozens of dedicated ports on the back of your machine.
Now, what's really fascinating here is how USB 4 actually manages all of that heavy multitasking without completely crashing your system. It uses this brilliant feature called dynamic bandwidth allocation. Let's say you plug in a 4K monitor and an external hard drive at the same time. The cable intelligently figures out exactly enough bandwidth to give to the monitor to keep your picture perfectly smooth. Then, it automatically grabs whatever bandwidth is left over and dumps it straight into your storage drive transfer. It's constantly adapting on the fly. Pretty smart, right?
And hey, if you need absolute maximum bandwidth, USB 4 version 2.0 arrived in 2022, pushing standard speeds to 80 gigabits per second. But they went even further. Using something called asymmetric modes, if you have a massive display setup, the cable can actually reduce bandwidth in one direction to push up to an insane 120 gigabits per second in the other direction. That is perfectly designed to run 16K resolution displays, professional editing arrays, and really demanding high-end AI workloads.
All right, our final section, Section 5, Shape does not equal speed, the golden rule.
If you take anything away from this explainer, let it be this. You absolutely must separate the communication version from the physical connector shape. They are not the same thing at all. The version, like USB 2.0 or USB 4, that dictates the technology and the speed. The connector, that's just the physical shape of the plastic and metal. Type A is that classic big rectangle on old PCs. Type B is the chunky square one on printers. Micro USB dominated older Android phones, and Type C is that modern reversible oval we all use today.
Remember this golden rule. You can't judge a book by its cover, and you certainly cannot judge a USB cable by its shape. Many cheap phones and devices out there will slap a fancy, modern Type-C shape on the outside of their product, but on the inside, they still wire it for painfully slow, 2-decades-old USB 2.0 speeds. It's a total bait and switch.
So before you buy a new device or try transferring massive files on your brand new laptop, check the actual specifications on the box. Don't just look at the port. Ask yourself this. Are those modern-looking Type-C cables sitting on your desk right now actually wired for speed, or are they just a slow 20-year-old standard hiding in a modern disguise?